Okay, welcome back everyone. Today we are going to focus on solving linear inequalities. So solving inequalities is basically just like solving equations. The main difference is now you're going to get a range of solutions that make the inequality true instead of just getting like one answer. But you'll also still will get no solution or infinitely many, which we said was all real numbers sometimes. And instead of just solving it like it's an equation, now we're also going to graph it on a number line. So there's first a couple things that you really want to know when solving inequalities. The first is sometimes you're going to use an open point like that, and sometimes you're going to use a closed point. You use an open point or an open circle when you have less than or greater than. Let me highlight that. And use a closed circle or closed point when you have less than or equal to or greater than or equal to. So, what does each represent? An open circle represents no equality. So, if I have an open circle, that basically means that the point on that circle, exactly that number, is not a solution, because less than or greater than means the solutions are strictly bigger or smaller than that number. That number is not a solution. A closed circle means that there's equality here. So if you look at this line underneath, less than, that means less than or equal to. This means greater than or equal to. So if you have a closed circle or a closed point here, you are saying that on that point, that number is also a solution, which is meant by less than or equal to or greater than or equal to. It could be bigger than that number or exactly that number, or it could be smaller than that number or exactly that number. And now which way will you shade? Say, for example, you had x is greater than 2. How you would shade that is, first of all, since it's greater than at 2, you would have an open circle. You don't see any equality. You don't see a line under the inequality sign. Since it's greater than, that means bigger than 2. All the numbers bigger than 2 are to the right, so you shade to the right. If I had x is less than 2, I would also have an open circle at 2. But now I want the numbers that are smaller than 2, which are to the left on a number line. And if I had less than or equal to or greater than or equal to, it would look just like that. But instead of an open circle, I would have a closed circle. Okay, so now we're going to incorporate our solving and then graph it on a number line. So in number 1, we have negative 4y plus 23 is less than 67. So we're going to solve it just like that was an equals. First thing, we have a two-step equation here. Let's subtract 23 to both sides. 67 minus 23 is 44. And now to get rid of that negative 4 in front of the y, the current operation is multiplication. How do you undo that? You undo it with its inverse, which is division. The only thing you have to remember, and I might put a star or write this down somewhere, anytime you're working with inequalities and you end up multiplying or dividing by a negative, you're going to have to flip the inequality sign. When you multiply or divide by a negative. So when we divide by this negative here, we have to flip. We had less than, so it changes to greater than, and 44 divided by negative 4 is negative 11. So now when we graph that on the number line, we put a point, negative 11. It's going to be an open circle because we just have greater than. We don't have greater than or equal to. Greater than means shade to the right. And one reason why you're flipping that inequality sign, think if you had this statement here. Oops, sorry. If I had 3 is greater than 2, that would be a true statement. But let's think if I made them both negative. If I divided them both by -1 or multiplied by -1, it would become -3 and -2. Is -3 greater than -2? It's actually not. -2 is bigger than -3 because it's closer to 0. The reason you flip the inequality sign is because when you're working with negative numbers, it's actually the reverse thinking than when you're working with positive numbers. When you're working with positive numbers, the further away from 0 you are, the bigger. When you're working with negative numbers, the closer you are to 0, the bigger the number. So that's why we flip the inequality sign there. Okay, so now we're going to also introduce some new topics here, but they're not super difficult. It just takes a little bit of remembering which is which. Set notation. The first thing you're going to need is a set bracket. Don't worry if these are hard to draw at first. You get really used to them. So they're also called braces. Basically, it's kind of like a squiggly line and then like a point. Those are for set notation. And all you do for set notation is you name what your variable is that you're working with. So we are working with y in this case. And you put a line here, kind of like an absolute value bar, which means such that in math. And then you put what your solution was. Our solution is y is greater than -11. So that's it for set notation. Now interval notation is a little bit trickier. So interval notation, what you're going to do is the first thing you need to do is you need to consider, is it an open or a closed circle? So if it is open, you are going to use a parenthesis. If it is closed, you're going to use a bracket. Another thing you really want to remember about interval notation, anytime you're working with infinity, you want to use parentheses or negative infinity. Okay, so open, the parentheses mean it's not included in the solution set, and the brackets mean closed. It means that number is included in the solution set. So if we look at ours, -11, it's an open circle, which means -11 is not a solution. So -11, it's going to be a parenthesis. And we're looking for the interval that's the answer. So basically what you're trying to do is you're trying to write in numbers what that shaded region right here is. So we go from left to right, reading that. We go from -11 as an open circle, and we're going right forever. If you're going right forever, you're going towards positive infinity. And this is the symbol, like a sideways 8. That's the infinity symbol, and you always use parentheses with infinity. So that is your interval notation right there. If that is tricky or it seems kind of confusing at first, that's definitely something that takes a little bit of time getting used to. So don't be worried if it is something that seems a little confusing at first. Okay, so now taking a look at number 2. First thing we need to do is we need to simplify this, just like our solving equations. So here we have a lot of different grouping symbols. I see some brackets. We have some parentheses. Whenever you have multiple grouping symbols, you want to work from the inside out. So I go all the way on the inside to these parentheses. Go to my parentheses first, and I work with my distributive property. Well, I see negative parentheses. That's an invisible -1. And if you remember from the earlier videos of solving equations, you need to distribute first. So I write everything exactly the same and now I distribute. Negative 1 times 3x is negative 3x. Negative 1 times 1 is negative 1. Once you distribute, your parentheses are eliminated, but our brackets are still there. And then on the right side, 3 times x is 3x. 3 times negative 2 is negative 6. Once I distribute, the parentheses are gone. After you distribute, you always want to see if you can combine like terms on the same side. So I look inside this bracket, I have some like terms that I definitely want to combine. Negative 2x minus 3x is negative 5x. And now those brackets are just basically the exact same thing as parentheses. And what I need to do is I have a negative 6 outside parentheses, which means I need to distribute. So negative 6 times negative 5x is positive 30x. And negative 6 times negative 1 is positive 6. And now, just like with equations, I need to get all of my variables to one side. This is where you definitely want to move the smaller one to the other side. So I'm going to get rid of the 3x by subtracting it. 30x minus 3x is 27x. And now we need to get x by itself, so subtract 6. Sorry, I'm running out of room here. And then your last step to get rid of the 27, divide. So we have x is greater than or equal to negative 12 over 27. But just like before, remember we always want to simplify or reduce our fractions if we can. So we think, does 12 and 27 have anything in common besides 1? Any factors that go into them? And they do. 3 goes into both of them. So if we divide negative 12 by 3, we get negative 4. If we divide 27 by 3, we get 9. So our answer is x is greater than or equal to negative 4 over 9. Notice I never actually divided by a negative number, so I didn't need to flip the inequality sign. Okay, so now plotting this on the graph or the number line. So negative 4 over 9. I have a closed circle this time since it's greater than or equal to. Greater than means you shade to the right. Okay, so set notation. Remember, set notation is you just use these squiggly braces or set brackets. And what you're going to do is name what variable you used. We used x, such that, and you put your answer. And now with interval notation, we're trying to write what that interval or shaded region is. What are the answers? So the leftmost point is negative 4 over 9. Since it is included in the solution set, it is a closed circle, which means that could be an answer. We use a bracket this time. Put a comma in between. And what's the rightmost number? How far right does this thing go? It goes right forever with that arrow, so it goes to positive infinity. With infinity, you always use a parenthesis. So yes, you can have sometimes one side's a bracket and the other is a parenthesis. That's perfectly fine in interval notation. Okay, so now let's move on to number 3 here. Sorry, I kind of got into this. Okay, so what we're going to do here is we're going to work from inside out. So I definitely want to go to these parentheses first. And we have a negative outside parentheses, which means it's an invisible negative 1. We need to distribute first. These arrows just mean multiplication. So rewrite everything exactly how it is, except distribute. Negative 1 times x is negative x. Negative 1 times 3 is negative 3. And notice our parentheses are gone after we distribute. Negative 4 times x is negative 4x. Negative 4 times 9 is negative 36. And just like in the last problem, we want to combine like terms before we move on. So on the left side, I have a 2x minus x inside the brackets. 2x minus 1x is just x. And now the exact same thing as in the last problem. There's nothing we can do inside those brackets, so they're just acting as if parentheses. We have a negative 4 outside, so we still need to distribute that negative 4 to each of those. Negative 4 times x is negative 4x. Negative 4 times negative 3. Negative times a negative is a positive. Okay, so now what we have here is we have negative 4x, and we notice, well, we have the same thing on both sides. So if I added the 4x, this is starting to seem like those special cases we talked about with equations. We no longer have an x. So now I have 12 is greater than or equal to negative 36. So let's think about that. When is 12 greater than or equal to negative 36? Well, 12 is always greater than or equal to negative 36. So this is always true. If something is always true, we know that the answer is all real numbers are going to make this true. So let's think about that. What should I shade on the number line if every number makes this true? We need to shade the entire number line. And feel free to try it out. Pick any number for x, plug it into both sides for all the x's. It's always going to be a true statement. So all real numbers are working for this inequality. Okay, so how do you write in all real numbers in set notation? What you're going to do is, just like before, we're going to use our braces or our squiggly brackets, like I like to call them. You name your variable, which is x. And now this time, since it's all real numbers, instead of writing out all real numbers, we use the symbol, which is this r, with kind of two lines to the left. And you use the symbol element. So it's like an E, and then you put the all real numbers symbol. So anytime the answer is all real numbers and it's an inequality and you need to write set notation, you write it just like that. And that reads, x is an element of all the real numbers. Okay, and then the interval notation, well, it's just every real number. So how far left is this graph going? It's going left forever. Left forever goes to not positive infinity, it goes to negative infinity because left, those are the negative numbers. To the right, it's going to positive infinity. And then with both infinities, we always use parentheses with the infinities. And then our last problem right here is number 4. So now we have parentheses, we don't have brackets, so it's going to be less steps to solve it. We just have to distribute. 1/2 times 8x is 4x. 1/2 times negative 6 is negative 3. And on the right side, negative 2 times 3 is negative 6. And negative 2 times negative 2x is positive 4x. And then we always look to combine like terms on the same side before we do anything. So negative 3 plus 1 on the left side would be negative 2. And 4 minus 6 on the right side would also be negative 2. And you may start to notice here that, oh, it looks like we have the same thing on both sides. So when we had the same thing on both sides for equations, we would say it's all real numbers. When we had different numbers on both sides or different things, but they would cancel out with the variables, we would say it was no solution. But if you take a look at number 3, we had different things on different numbers on both sides, but we said it was all real numbers. So it's very, very important with inequalities that you check your answer to see if it's a true or false statement. to decide if it's all real numbers or no solution. Okay, so what we're going to do, just to make it easier to think about, we're going to subtract 4x to get rid of that from both sides. And we have -2 is greater than -2. So now I need to think about this. Is that a true statement? Is -2 greater than -2? So is -2 bigger than -2? No, it's actually equal. And we don't have the equality, we don't have the line underneath it, so this is not a true statement, so this is false. If we have a false statement, we said before it was no solution. So now, let's think about this. If there was no solution, should I shade anything on the number line? You do not have to, if you have a no solution inequality, you do not have to shade anything on the number line. You just leave it blank because no number on that number line is going to make that inequality a true statement. And now if you think about it, your set notation and your interval notation, we can't have an interval if we don't have any numbers shaded on the number line. And for your set notation, you really don't need to write your set notation as long as you write no solution, or you could put the symbol for no solution, which is a 0 with a line through that. That is plenty fine for your answer for a no solution problem. Okay, so that is it. Today's lesson had a lot of information, so feel free to pause it at any points. And if you need any further explanation or you're not sure on something, feel free to ask whenever you want.